Okay class, so now we go to one question. Kita tengok macam mana kita nak apply the Newton's law to solve this problem. For example, 3a, question 3a. We have a 3 kg cube. I have a cube. I place it on a rough planes. Then the plane is then slowly tilted until the cube start to move from rest. So we tilt it until the cube start to move from rest. And we find out that this occurs when the angle of inclination is 25 degrees. So calculate the coefficient of static friction between the cube and the rough plane. So the question asks us to find the coefficient of static frictions that exist between the cube and the rough plane surface. So for this question, we find out that the cube start to move when the angle of inclinations is 25 degrees. Okay, so we want to find the coefficient of static friction. So if we refer back to our concept we learned about the forces, we find out that for static frictions, when the object is just start to slide at the verge of the motion, the static friction force is maximum. The static friction force is maximum, and this maximum value can be calculated using the equation Fs maximum is mu Sn. Mu S is referred to the coefficient of static friction. N is the normal force. N is the normal force. So means that I'm going to use this equation to calculate the coefficient of static friction. So to solve this problem, the first step, I'm going to draw the free body diagram so that I can include all the forces that acting on the cube beside the static frictions. Then I'm going to choose the axis. Then resolve the forces into x and y component. Then only we able to apply the Newton's law to solve the problem. So first, I'm going to draw the free body diagram for the cube. So this is the cube. So I redraw free body diagram. So this is the inclined plane at an angle 25 degrees. So I represent the cube with a dot. So what forces we have for this cube? So first we ask ourselves, is there any mass for the cube? Yes, so we have weight straight downward, W, and then the cube is put on the surface. So perpendicular from the surface, we have normal reaction force, M. And then, is there any tension? No, there will be no tension because we didn't attach any string to the cube. Okay, then is the surface rough? Yes, we want to find the coefficient of static frictions. It means that there must be a static friction force acting. So, if you see from the video just now, when the cube start to move, it will slide down. So our friction force will always parallel to the surface. Our friction force will be always parallel to the surface, but then acting opposite to the motion. So the cube tend to slide down, so our friction will acting along the inclined plane, but acting upwards. Okay, so this is our static frictions, which is maximum. Because when at angle 25, the object is already start to move. So at that particular moment, our static friction is maximum. Okay, so this is the three forces acting on the cube. So I already done with the first step. I have already drawn the free body diagram. Then I'm going to choose the axis. So just now we already said treat the direction of motion as one of our axes. So since the cube will move along the inclined plane, so I treat the inclined plane as x-axis. So perpendicular to the inclined plane as y-axis. Okay, so saya letakkan kat sini. So this is our y-axis. This one will be our x-axis. So I choose along the inclined plane as our x-axis, perpendicular to the inclined plane as our y-axis. Okay, so after I put my axis, and you can see obviously our normal force is point along the y-axis. Our friction force is acting along the x-axis. But then our weight, the weight of the cube is acting at a particular angle. Okay, so the weight need to be resolved. So we follow the third step, we have to resolve the forces. So normal is along y-axis, no need to resolve. Frictions is along x-axis, no need to resolve. But weight have an angle. So kalau you perhatikan, Cici panjangkan benda ni. So you akan nampak sini 25. So sini akan jadi berapa? 90 tolak 25. So dia akan jadi 65. Okay, so kalau sini 65, maksudnya sini adalah 25 lah. Sebab sini perpendicular kan. So sini 65, sini 25. Okay, so next time ingat angle dekat sini akan setara dengan angle di sini. So it will equal to this angle. So Cici padam yang ni. So the angle here will be 25 degree. So I'm going to resolve the weight. So kita resolvekan weight kepada x-axis. So the x-axis is opposite to the angle. The x-axis is opposite to the angle. So we have W sine 25. And then we resolve the weight to the y-axis. So here the y component will be W cos 25. Why? Okay, sorry. Okay, 25. Okay, so we have resolved it. Okay, so kalau you tengok Cici padamkan after resolve, so means that sekarang saya dah letakkan semua forces tu lah along y-axis dan juga along x-axis. So I have resolved all the forces into component x and component y. Then I can apply the Newton's law of motion. So which Newton's law of motion I need to apply? So I find the keywords in the questions. So the questions say, if you refer to the keywords in the question, it says the cube start to move from rest. It just start to move. Dia baru nak bergerak. So kalau you refer balik kepada handout kita tentang Newton's law, ataupun video sebelum tu, kita dah kata keywords just begin to slide, telling us that we still apply Newton first law. Waktu tu kita belum bergerak, objek tu baru nak bergerak, so dia masih berada dalam keadaan pegun, at rest. So we are going to apply Newton first law. Summation force equal to 0. Okay? for the both component. Okay, so we have this one now. So we are going to apply Newton's first law. We apply for the component X dulu. Kita apply untuk component X dulu. We apply for component X first. So summation force component X will equal to 0. So we have this one, W sine 25. Okay, but frictions is opposite to the W sine 25. So minus Fs maximum equal to 0. Okay, so how we find weight? Weight is equal to mg. Mg sine 25. So equal to Fs maximum. So we can find the value of maximum static friction. So teacher put in the value. The mass is how much? The mass is, how much is the mass? 3 kg, sorry. So the mass is 3 kg times 9.81 sine 25. So we get the static friction force when we do calculation with our calculator. So we have sine 25 times, so we have sine 25 times 3 times 9.81. So we have 12.4377. Okay, 12.4377. 4377. That one is our maximum static frictions. Okay, so I have kept my maximum static friction. Then, in order to calculate the coefficient of static friction, tengok formula dia. Nak cari coefficient of static friction, you kena tahu normal force juga. Sekarang Fs maximum you dah tahu, so you kena tahu normal force juga. So, where is our normal force? So, kalau you perhatikan, normal force act along y-axis. So, we have for the y-axis, the summation force along y-axis is equal to 0 also. Why? Because the object didn't move along y-axis. Dia tak ada terbang ke atas. So, summation force component y 0. So, normal upward, positive. But W cos 25 is opposite to the normal. So minus W cos 25 equal to 0. So we can find our normal force. So the normal force will be weight cos 25. So weight is mg. Weight is mg. So our m is 3. G is 9.81. Cos 25. So I'll get my normal force will be 26.6726 Newton. Okay, so boys and girls, we already get our normal force, we already get our maximum friction force, then we can calculate the coefficient of friction. So we know that the maximum static friction is mu Sn. So we can find our mu S. Mu S will be Fs maximum over N. So it will be 12.4377 over 26.6726. So I'll get around 0.466. Okay, so maybe you ask, teacher, any unit for coefficient of friction? So you perhatikan, static friction force is Newton. Normal reaction force is a force. The unit is Newton. So Newton and Newton cancel. So there will be no unit for coefficient of friction. So for coefficient of friction, tak ada unit, so the value is 0.466. Then we have solved our question. Okay. So you might try the similar questions. So take some time. So you try question 3B, which have the quite similar solution step. Okay, you can try question 3B.